Good day to everyone, especially to you, Ma'am Leo de Vidal Agrada. I am Teresa Joy Masliones, the leader of Group 6, along with my group members, Palma Jazel, Nadera Ria, Halasha Rhea May, Medica Rowena, and Uday Edith. This is the GE4 Mathematics Role Play Presentation.
The friends suddenly discussed their lessons in mathematics.
I really like our class today.
Yes, we learn a lot, guys. A lot of knowledge.
And even if it's all about mathematics, but it's really fun to learn it.
And also, even we had the 3 topics to study in math, still is it fun and we like it so much.
And our professor is kind by the way.
Yes, guys.
By the way, guys, what are the 3 lessons that we discussed earlier?
It is all about the measures of variation, z-scores, and box and whisker plot.
Measures of variation describe the width of a distribution. They define how spread out the values are in a dataset. They are also referred to as measures of dispersion or spread. Range. Range is the simplest measures of variation. The range of dataset is the difference between the highest value and the lowest value in the dataset. For example, in 4, 6, 9, 3, 7, the lowest value is 3 and the highest value is 9. So the range is 9 minus 3 equals 6. The interquartile range or IQR describes the middle 50% of the values when ordered from lowest to highest value. When a dataset has outliers of extreme values, we summarize the typical using the median as opposed to the mean.
Variance. Variance is a statistical measurement that is used to determine the spread of numbers in a data set with respect to the average value or the mean. Using variance, we can evaluate how stretched or squeezed a distribution is. Suppose we have the data set 3, 5, 8, 1. The mean is given as 3 plus 5 plus 8 plus 1 over 4 is equal to 4.25. Then by using the definition of variance, we get 3 minus 4.25 multiplied 2 plus 5 minus 4.25 multiplied by 2 plus 8 minus 4.25 multiplied 2 plus 1 minus 4.25 multiplied by 2 over 4 is equal to 6.68. Standard deviation. Standard deviation is a measure of how much data values deviate away from the mean. Larger the standard deviation, greater the amount of variation. Standard deviation is a statistical measurement of the amount a number varies from the average number in a series.
The z-zeros of raw data refers to the score generated by measurement. How many standard deviation are above or below the population mean? It helps in testing the hypothesis under consideration. The z-scores have a mean of 0 and a standard deviation of 1.
The equation for the z-score of a data point calculated by subtracting the population mean from the data point, referred to as x. Then, the result is divided by the population standard deviation. Mathematically, it represents as z-score equals data point minus mean divided by standard deviation. So this is the formula for the z-score. Let us take the example of a class of 50 students who wrote the science test last week. Today is the result day, and the class teacher told me that John scored 93 on the test while the average class was 68. So first, let's determine the z-score for John's test mark if the standard deviation is 13. Let's use the formula for the z-score, which is z equals data point minus mean divided by standard deviation. So 93 minus 68 equals 25. And 25 divided by 13, which is the standard deviation, equals 1.92. Therefore, John's test score is 1.92 standard deviation above the average score of the class, which means 97.26% of the class that contains of 49 students scored less than John. So let's take another example, guys, in order you to learn and understand more in this kind of lesson. Let's just say that you have a test score of 190 and the test has a mean of 150 and the standard deviation of 25. So z equals 190 minus 150 divided by 25. So 190 minus 150 equals 40 and 40 divided by 25 equals 1.6.
Box and whisker plot. A box and whisker plot, otherwise known as box plot, is a graph summarizing a set of data. Shape of the box plot shows how the data is distributed and it also shows any outlier. So there are a couple of things you should know in order to work with box plots. Lower extreme, the smallest value in a given dataset. Upper extreme, the highest value in a given dataset. Median value, the middle number in the set. Lower quartile, below that value, the lower 25% of the data are contained. Upper quartile, above that value, the upper 25% of the data are contained. Whiskers, the lines that extend from the boxes, they are used to indicate variability out of the upper and lower quartile.
Suppose an IT company has two stores that sells computer. The company recorded the number of sales each made each month. In the past 12 months, we have following number of sold computers. Store 1. First, we put the data and standing order. Now, we need to find the median. However, this is even set data. There is one middle point. The middle and our case belong to 6 plus 7 data points, 250 and 290. Divided 2. Median is 250 plus 290 is divided 2 equals 270. There are 6 numbers below the median. Lower quartiles is the median of these 6 items, so third plus fourth data points is divided 2. 160 plus 200 is divided 2 equals 180. There are also 6 numbers above the median. Upper quartiles is the median of the 6 data points. Third plus fourth data points is divided 2 equals 420. Finally, the number summary for sale is 20, 180, 270, 420, 580. 5 numbers summary for store 2 is 70, 160, 320, 470, and 630.
Thank you for your time, guys. Bye-bye!